In the case of grouped data, the variance and standard deviation are given by these formulas. We have also population variance and we have sample variance. And of course, the standard deviation would be the square root in this case, and also would be square root in this case. So as you see, the difference is that we still have n minus 1 for sample and n for for population. And also here, instead of the values x, now we have the midpoints representing the class and the frequency of a class. So we need to calculate sigma m square f and sigma mf for every class. So let us see an example how we calculate the square of the midpoint multiplied by the frequency for every class, and the midpoint multiplied by the frequency for every class, and then we get the sum in both cases in order to use this formula. So let's have a look at an example. Let's calculate the standard deviation for the following sample data. So in this case, I need to calculate the midpoint for every class. So let's calculate that. Let's try to build here column for the midpoint. Okay, and the midpoint for the first class will be the average of 1 and 3, which is 2, and then the second class will be 5, and then keep adding 3 because the class width here is 3. Can you see the class widths from 1 to 4, from 4 to 7, from 7 to 10? I keep adding 3, so the class width is 3. So 7 to 9, the average will be 8. Just keep adding 3, so that will be 11, 14, and 17. So these are the midpoints. So now I have the midpoints for the classes. Now I need to calculate MF because I remember the formula needs the product MF, the midpoint of every class multiplied by the frequency of every class. So let's do that. MF is 2 times 1, which is 2 for the first class, 5 times 3 is 15, 8 times 0 is 0, 66, and then 5 times 14, how much is that? I need a calculator for that, I think. Okay. So that's 5 times 14, that's 70, okay. And then 2 times 17, that is 34. Okay, so I got the midpoints, multiplied by the frequency. So what else we need? If you look at the formula, we in fact need MF, and we also need M square F. So we need to prepare now M square F for every class. So let's do M square F. Okay, so another one here. That would in fact be M square F. So M square F will come from where? It will come from multiplying M by itself and then the frequency. So M times itself, which is 2 square multiplied by 1. 2 square is 4. So 4 multiplied by 1 will be 4. See, another way you can get it is multiply the midpoint by the midpoint times frequency, because you already have M here and you have MF here, so if you multiply these two, you will also get M square F. So you can just multiply these two numbers, 2 times 2 give you 4. 5 times 15, okay, 5 times 15 is equal to 75, so come here, 75. Of course, this would be 8 times 0 is 0. Okay, that's M multiplied by MF will give you M square F. Remember, so I'll just multiply 11 times 66. This will give me 726. Okay, and then again, M square F, you can square this 14 and multiply it by M as another choice. So let's do that. M square F is just M multiplied by M multiplied by F. That's the idea. M times F. So I can just say that, just to try it for you. 14 times 14 times 5. That gives me 980. Okay. 980. And finally, 17 squared times 2. I'm choosing another way to do it. Remember, I can just multiply 17 times 34, or I can square 17 and multiply it by 2. So here I'll choose to square 17, which means I multiply it by itself, and then multiply it by 2. Okay, that's 576. Same thing if you multiply 17 times 34. Yeah, same thing. 578. Okay, that's 578. Okay, now I got m squared f for every value. Now I need to get the sum at the end. Okay, for all of these quantities. So let's say the sum here for these quantities will be what? The sum of mf and the sum of m squared f is actually what I need. So let's try to get the sum for these quantities. Okay, so for the mf, we'll add them 2 plus 15 plus 0 of course plus 66 plus 70 plus 34. That's equal what? That's equal to 187. So I have this here, 187. Okay, so I got the sum of mf. I need to get the sum of m squared f as well. So that will be 4 plus 75 plus 0, which next is 726 plus 980 plus 578. Okay, so the sum here is 2363. Okay, it's 2363. Okay, so now I got the sum in both cases. Remember, this is 6 actually, it's not 0, it's 6, because some people might think. Okay, so I got these two sums. Now I'm ready now to use this formula. So let's start using this formula. Sigma m square f minus sigma mf all square divided by n. Okay, so in fact here what I need is the sum of mf square. Not this sum as it is. I need to square this to be part of the formula. Let me write the formula for you. Okay, I need what? I need sigma m square f minus sigma mf all square. All of this will be divided by n, right? Because in this case I have sample and then divide by n minus 1 at the end. This will give you what? This will give you the variance. This will give you s squared, by the way. Okay, this will give you s squared. Okay. So the question is asking for standard deviation. So don't forget to get the square root at the end. After you calculate the variance, you get the square root for the standard deviation. So anyway, the first quantity would be m squared f, which already I got the sum here, which would be 2363, minus the second quantity that you got here, which is 187. This must be squared first, and then you divide it by n. And n in this case, a lot of students by mistake think that n is the number of classes. 1, 2, 3, 4, 5, 6. 6. No, that's a mistake. That's a mistake. N is a data size. N is a data size. So remember that this n actually is the data size. Data size. And data size n equals sigma f. So sum of the frequency. So the sum of the frequency here, you need to get the sum here of this frequency. Okay, let's just get that sigma f is equal what? Let's just use another color because this may not be very clear. Okay, sigma f, okay, the data size, which is n, in fact is to add all these frequencies. 1 and 3 is 4, 4 and 6 is 10, and then it's 17. Okay, so the data size is actually 17. Okay, so this will be it. This will be 17 here. And when you divide the total quantity, denominator down, will be 16 because it's n minus 1. Okay, so let's do that. First of all, you need to calculate this quantity. Square it and divide by 17. Let's do that first. 187. When you square it, which means you multiply by itself, and then you divide it by 17, the result is 2057. And as you can see, the result is smaller than this one. and it has to be smaller because the answer must be positive. If it is not smaller, it means you made a mistake. Okay, so it's 2057 minus 2057, and then I divide by 16. So obviously I need to subtract this first because a lot of people make mistake here when they use a calculator. I'll tell you what the people mistake. What the students usually or sometimes do is they say, okay, 2363 minus 2057 divided by 16. And that's wrong. This will give you the wrong answer. This is not the right answer. You know why? Because you divided only the second one. We should divide the difference. So the right way to do it is to either put bracket in the beginning. So you have 2363 and then minus this 2057. Okay, and then close the bracket. So when you close the bracket, you're actually getting the difference. And this difference is what should be divided by, this should be divided by 16. So this will give you the right answer. Okay, this will give you the right answer. Okay, 19.125. Okay, so another way to do it is actually, if you want, you can actually just get the difference 2363 minus 2057 and then hit equal so that you get the difference. Make sure you get the difference, and after you get the difference, now you can divide it by 16. Okay, so please try to avoid these mistakes. Okay, now I got what? I got, in fact, the variance. This is what now? This is the variance. Okay, this is the variance, the sample variance. Okay, remember the question was the standard deviation. So the standard deviation, you need to get the square root of this number. So the standard deviation, which is actually required in the question, is the square root of this number, 19.125. And remember, use this as accurate as possible because you still have to get the square root of it. So some people round this to 19, for example, and then get the square root. That's not a good practice. If you use any number, use it as accurate as possible. Okay, so we're using it here to get the square root for the standard deviation, and now to get the standard deviation, get the square root for this number. Okay, here is the square root. You just get the square root of this number. Okay, so that's it, 4.37 approximately. This approximately is 4.37. Okay, so this will give you an idea of how we calculate the standard deviation for grouped data in the case if the data is sample data. Of course, if the data is population, that's not a big deal. All what you have to do is to make this capital N, but everything else remain exactly the same. If it's population, just divide by N instead of N minus 1, and everything else remain the same. And if I don't want the standard deviation, if I want the variance, then you stop here and no need to get the standard deviation, don't get the square root. Again, if I ask for the variance and you give me this as a final answer, you lose half mark, because unless if you clearly write this is variance, this is standard deviation. And if I ask for the standard deviation and you stop here, you lose also half mark. So be careful the difference between variance and standard deviation, and also be careful about the data if it's sample data or population data.